Start. So, good afternoon, guys. Welcome to NEET World Institute and NEET World YouTube channel. So, in this session, we are going to concentrate on this fluid topics. Okay, so the topic where we have left in the last class. So, this was the problem we have seen in the last class, right? The two side angles of different cross section areas, right? So, the next question of this is, in a car lift compressed, air exerts force F1 on small piston. Okay, F1 on small piston having a radius of 5 centimeter, and this pressure is transferred to the second piston of radius 15 centimeter. Right now, so like let me take down small piston. Small piston. So force is F1 and the radius R1 is 5 centimeter. No, I can write this as 5 into 10 power minus 2 meter. Got it? Yes, no? Now, if the mass of the car lifted is, so if in a car lift compressed, air exerts a force on smaller piston. Okay, in the second piston it is radius 15 centimeter, which is a larger piston will take. Okay, second piston. Second piston. How much radius? 15 centimeter. 15 centimeter in the sense it's a larger only, no? Large piston, which is equals to 15 into 10 power minus 2 meter. Okay. If the mass of a car to be lifted is 1350 kg, calculate F1. So I need to calculate F1. So here mass is given as M2 is given as 1350 kg. What is the pressure necessary to accomplish this task? Okay, so what is the pressure they are asking? Pressure will be same. I can find any of these two pressure, but what is the force they are asking first? Right now, we know that whenever we take a thing like this, it's a larger piston, it's a small piston. When I apply some force here, P1, opposite side also same force P2. So can I say that P1 is equals to P2? Right? No. So what is P? Force by area. So F1 by A1 will be equals to F2 by A2. F1 I don't know, I need to find out. I'll keep as it is. Area A1, no, like let me take in a centimeter only. Centimeter and centimeter will get cancelled off. Okay, I'll keep centimeter only. Pi r square. Right now, area of the circle, pi r square. So pi into r is 5. No, here it is 5 square will be equals to F2 is, what is force? Mass into acceleration we know. Force is mass into acceleration. Mass we know, and acceleration is due to gravity. Right. So 1350 into 10 divided by, what is the area of the second one? Pi r square. Pi r2 square, no? Pi into r2 is 15 the whole square. Got it? 15 the whole square. Now if I calculate for this, F1 will be equals to how much? 13. This pi will get cancelled. 1350 into 10 divided by 15 into 15 into 5 into 5. Correct? Correct? No? Now what happens here? This is 3 times, 1 time, 3 times, 1 time. Right? Once, and this is 4, 1 is remaining 5, 0. And again this one, 150 times. So 1500 Newton. F1 is 1500 Newton. Got it? We got F1. Force F1 we got that as 1500 Newton. What is pressure? Pressure is nothing but force by area. So can I take any force here? Any force like P1 is equals to P2 is equals to, right? F1 by A1 will be equals to F2 by A2. Anything I can find, right? So if I take the second one or first one also, first one 15 divided by pi into 5 square. So I get the pressure, right? No, so it is 1500 divided by 22 by 7 into 5 into 5 into 10 power minus 2 into 10 power minus 2. Because we are calculating in the SI unit, right? So we will calculate like this. Got it? This is the answer for pressure and the force. Okay, you can take a note of this. We can go for the next one.
Sir, what do you think about the foreign university campus opening in India? Like which university opened, man? Name the university.
Done, right? See, here they have taken 9.8. We have taken 10. So we'll get approximately 1500. They have got exactly like 1470 Newton. Okay, now next one is, yeah, this is the next important topic, right? So now till now we were discussing about a liquid where it has not been accelerated, liquid at rest, liquid at rest, which means I can find the velocities. It will be same, right? Now like this velocity will vary, but this velocity will be remain same. But when it accelerates, no, it will change. When it accelerates, it will change. So that's the thing we are going to discuss in this topic. So vertically accelerated vessel. What is the meaning of vertically accelerated? Vertically accelerated means it will accelerate either this topward or bottomward. Okay. So G effective will be based on the gravity also. Like this is the acceleration, for example. So it's going upward, right? No. For this, what is G effective? G effective will be equals to, right? So one is upward direction and this also, I mean this is upward direction, but gravity, let me take gravity, okay, that is downward direction. When both are in opposite direction, G plus A, okay, G plus A. When both are in same direction, what happens is G effective will be equals to G minus A. When A and G are in opposite direction, when they are in same direction, okay, take it. Done? Got it? Now, initially when they are accelerated, when not accelerated, now what we will take? The pressure, this is PA and this is P. So P will be equals to PA plus rho GH. No, instead of G, we will use this G when they are accelerating upward or downward. Okay, that's the thing here. Okay, what is the thing? Okay. Some people will come on the next of the classes. Yeah. So buoyant force in accelerated motion. So buoyant force is nothing but it's opposing force, right? When I keep an object, right? No, like the object will go downward because of the weight of the object, right now. But the opposing force also will be there. That opposing force in a liquid is called as buoyant force. Okay. The buoyant force formula is F is equals to V rho G. Okay, F is equals to V rho G. When it affects, no, when G effective, no, when they are in accelerated vessel. Accelerated vessel in the sense, when acceleration upward, what I should take? G effective will be equals to G plus A. When accelerated downward, G effective will be equals to G minus A. Because these both are in opposite direction, these both are in same direction, G and A, and this is A and this is G. Got it? So G effective, G plus A in upward direction, acceleration upward. Right now, G minus A is downward direction. Got it? Done. Abdul completed? Okay. So we'll learn about what is buoyant force. Okay. So buoyant force is nothing but when an object is immersed, no. Okay, when upward force acting on a body immersed in a fluid, that is called as upthrust, we'll say, or also buoyant force. Upthrust we have read right now, which is opposing force when object is kept in the liquid, right? So the force and this phenomena is called as buoyancy. Got it? So Archimedes principle, it states that when a body is partially or wholly immersed. What is the meaning of partially and wholly immersed? So partially immersed in the sense object has been immersed only some part. Whole immersed in the sense a full part of the object has been immersed. It experiences upward force that is equal to thrust, like thrust. Okay, whatever the object, like suppose half of the object has been immersed, like equal to that weight, the upward thrust also will be acting. Got it? So upward thrust equal to the weight of a liquid displaced by it, and upthrust acts through the center of the gravity. It's always center of gravity. Center of gravity in the sense, like it's not about the liquids, so the objects which we have taken, no, that center of mass we have studied in the system of particles, no, that same concept we are going to use here, right? So this is the formula for this apparent weight. Apparent weight is nothing but the actual weight minus the buoyancy weight. So buoyancy weight, buoyancy force we have seen over here. What is the formula here? V rho G. Okay, V rho G. So if you see here the principle between the apparent weight, actual weight and the buoyancy weight. Actual weight of the object, apparent weight is the displaced amount of the and buoyancy weight. Okay, so W into 1 minus rho by sigma. Okay, take it. Done. Okay. So we'll see the topic first about the fluid dynamics, and then we can go for the center of mass, that one. Okay. So fluid dynamics is the study of the fluid in motion, right? So till now we were discussing about the object which are kept in a rest, no? Right? No. So from now we are going to concentrate on the motion of the object, that is motion of the fluid. Okay, so instead of applying Newton's law of every particle, we study properties like velocity, pressure and density at a fixed point in a space. Okay, so assumption for ideal fluid. So first of all we are talking about what is the ideal fluid. Okay, so what is the first assumption is it's a non-viscous fluid. Okay, no internal friction between the adjacent layer. Suppose if I talk about this is the surface, no, there will be a layer which is attached with the surface. So again the second layer will be there, third layer will be there, and the fourth layer, and goes on. Okay, what they are saying is there is no internal friction between the adjacent layers and no loss of energy due to viscosity. So when there is no friction, when there is no internal friction, obviously there won't be any loss of energy. Okay, so the next one is steady flow. So velocity and pressure at each point remains constant. Steady flow in the sense object will be going in a constant velocity. So each point will be remains constant with respect to time. And what about the irrotational of flow? So a tiny paddle wheel placed in a liquid does not rotate. Okay, if object is there, liquid is at rest, if I keep any paddle, it won't rotate. But when they are in the motion, like a wave particle will take place. When I keep a pedal, it will automatically float and it will go in the forward direction, right? So fluid has no angular momentum over any point. So this is the first 3 points about the ideal fluid. Take it. Once you have completed, you can tell me, we can go for the next question, next topic.
Done, Abdul.
So the next one is type of fluid flow. So first one is steady flow. Okay. So in steady flow, fluid velocity at a given point does not change with time. So fluid velocity does not change with time. Second point is the path of a particle are called as streamlines. Okay, streamlines. And third one is streamline never intersects. Okay, so example, water flowing smoothly through a narrow pipe. So this is the first type, which is nothing but a steady flow.
You can take a note of this.
Done. So the next one is laminar or turbulent flow. Laminar and turbulent flow. So laminar flow, particle moves in a smooth parallel layers. Okay. And second point, velocity at each point may differ in magnitude, but direction remains parallel. Okay. So velocity at each point may differ, but the direction remains parallel only. Okay. So energy loss is low. Okay, in the previous case, no energy loss. It will be in a constant flow. And third, next one is a turbulent flow. Flow becomes irregular and zigzag. When it becomes irregular and zigzag, no, automatically it will get intersect. Right? So here the I level of energy loss will take place when they intersect. Because of the friction, it may lose the energy. So example, laminar flow, flow of oil in tin tube, and the turbulent is fast river stream or air around an airplane wings.
You can take it.
Completed. Now, so the next one is the meaning of eddy. Like we have talked about the eddy current now. So the eddy is a small will or circular motion, okay, of a fluid that forms when flow becomes irregular or disturbed. So in a laminar flow, fluid moves in a smooth layer, so there is no eddy formed here. And in a turbulent flow, no, the smooth layer break down and tiny whirlpools, that is eddy, appears there. Okay, so this eddy spins the fluid locally and wastes kinetic energy. So when we have rotating and intersecting, no, obviously the friction will take place and energy will be loosed here. Okay, this is about the eddy, which will be discussed in the 12th class, like eddy current. Okay, that is separate and this is separate. Okay, yeah. Next one is compressible and incompressible flow. So compressible flow is nothing but a density of a fluid changes with pressure, and incompressible is nothing but density remains constant. So it is common in gases, it is in liquid. Okay, so liquid incompressible and gas is compressible. Okay, this is about the basic difference between compressible and incompressible. So next one is rotational and irrotational flow. So rotational flow, fluid particle rotates about their own axis. Okay, and irrotational means do not rotate about their own axis. It will rotate. This also will rotate. Both will rotate, but it will rotate through the own axis. It does not rotate through the own axis. Okay, this is about the compressible, incompressible, rotational and irrotational. You can take a note of this. Done. So next one is, that's a fluid dynamics we have studied, right? So streamline flow. Every other particle which passes the second point behaves exactly as the previous particle. Suppose if I talk about the first point of the layer, no, the second point of the layer also will follow the first point, right? That's the thing. Streamline flow. So every other particle which passes the second point behaves exactly as the first point. Okay, as the speed of a water outflow increases, it loses the smoothness. Okay, when the speed increases now, it will lose the smoothness. Okay, take. tangent at any point in the direction of a fluid gives the velocity of the fluids. Okay, so if I talk about a straight parallel lines, no, it will be direction will be same. But when I talk about a curved lines, so how to find the direction? So I need to take the tangent, which means I can take a point, I can draw the tangent. So the tangent will give the direction of the velocity. Okay, so a flow in which the velocity of a fluid at a given point does not change with time. And this next point is the path taken by the fluid particles, no, under any steady flow is a streamline. Okay, so no two streamlines can cross each other. If they cross, no, what happens means an coming fluid particle can either one way or the other way. Okay, it will not be a steady flow. We cannot say when they are intersect, we cannot say that it's a steady flow. Okay, take it. Done? Yeah. So equation of continuity. Okay. So here what happens is whatever the flow of water coming in will be equal to the water which is going out. Okay. I'll give you the equation here for this. Yeah. So the equation of continuity is AV is equals to constant. Okay. Take it. Continue. So it gives us the flow rate. Okay, so like here volume flux has been given, right? In 12th class we will talk about the electric flux, which means the number of field line which passes in the certain area. Okay, so whatever the field lines passes now in that area, we will call that as flux. Like flux is nothing but the flow of electric field. Here volume flux is nothing but the flow of water or flow of the fluid, we will say. Okay. Completed. Done.